Have you ever stood beside a flowing river, mesmerized by its seemingly gentle journey, and truly considered its power? What if I told you that these serene waterways are Earth's most prolific, patient, and persistent architects, sculpting our planet over millions of years with an artistry that dwarfs any human endeavor? Forget the pyramids or towering skyscrapers. The Grand Canyon, vast floodplains, and fertile deltas of the world are testaments to a force we often take for granted. This isn't just water moving downstream, it's a geological ballet, a relentless transformation of rock into dust, mountains into plains, all orchestrated by the silent, ceaseless work of rivers. Prepare to look at every ripple, every bend, every stretch of flowing water with a newfound awe, as we uncover the incredible story of how rivers shape the earth over eons. Rivers are far more than mere conduits of water. They are dynamic systems, constantly engaged in a three-part symphony of destruction, transportation, and creation. This continuous process, known as fluvial geomorphology, is responsible for the dramatic landscapes we see around us, from soaring canyons to sprawling, life-giving lowlands. It's a testament to the immense power of sustained, small actions accumulating over unimaginable stretches of time, each drop of water, each grain of sediment, playing its part in Earth's grand geological narrative. Let's begin with the destructive artistry, erosion. Rivers are nature's ultimate sculptors, relentlessly wearing away the very bedrock and banks they flow through. This isn't a single, simple process, but a complex interplay of forces. One of the most fundamental is hydraulic action. Imagine the sheer force of water, especially during floods in turbulent rapids, slamming into cracks and fissures in rocks. It compresses the air trapped within, creating immense pressure. When the water recedes or the pressure lessens, the sudden release of this compressed air acts like a tiny explosion, weakening and eventually dislodging fragments of rock. Over millions of years, these tiny explosions, repeated endlessly, can carve out colossal features. Then there's abrasion, often called corrosion. This is where the river truly earns its title as a sculptor. The water isn't just flowing, it's carrying a formidable arsenal of sediment, sand, gravel, pebbles, and even boulders. These transported materials act like sandpaper, grinding, scraping, and wearing down the riverbed and banks. This constant friction polishes rocks, carves intricate patterns, and deepens valleys. The harder the rock, the longer it resists. But even the most resilient granite eventually succumbs to the incessant scouring of countless abrasive particles. Think of the smooth, rounded stones you find in riverbeds. They are direct evidence of this relentless grinding. Next, we encounter attrition, a less visible but equally vital process. As the sediment particles are transported downstream, they don't just abrade the riverbed, they collide with each other. These countless impacts cause them to break down into smaller, more rounded, and smoother fragments. Over vast distances and immense periods, a jagged boulder might be reduced to fine silt, testament to the sheer energy expended within the river's flow. This reduction in size makes the particles easier to transport further, perpetuating the cycle of erosion and deposition. Finally, there's solution, or corrosion. This is the chemical side of river erosion. River water, often slightly acidic due to dissolved atmospheric carbon dioxide and organic acids from decaying vegetation, can chemically react with certain types of soluble rocks, such as limestone. Over time, these soluble minerals dissolve directly into the water, being carried away in a dissolved load, invisibly diminishing the land. This process might not be as dramatic as the carving of a canyon, but its cumulative effect over millions of years contributes significantly to the reshaping of landscapes and the chemistry of our oceans. These four erosional mechanisms, working in concert, are the primary tools by which rivers reshape the earth, patiently dismantling mountains and excavating valleys one particle at a time. Once material is eroded, it doesn't simply vanish. It enters the river's bloodstream, becoming part of its geology sediment load, which the river then transports downstream. The capacity of a river to carry sediment is staggering, and it's influenced by factors like its velocity, volume, and the underlying geology. This transport occurs in several fascinating ways. The dissolved load consists of ions dissolved from rocks and soils, carried invisibly within the water itself. These dissolved minerals, often the result of chemical weathering, contribute to the salinity of the oceans, a long-term consequence of riverine processes. Then there's the suspended load, which gives many rivers their characteristic muddy or silty appearance, especially during high-flow events. Fine particles like clay, silt, and fine sand are light enough to be held aloft by the turbulence of the flowing water, remaining suspended indefinitely as long as the current is strong enough. During floods, this suspended load can be immense, turning entire rivers opaque with the sheer volumes of transported material. Finally, we have the bed load, comprising heavier, coarser sediments like sand, gravel, cobbles, and even boulders that move along the riverbed. This movement isn't constant. It occurs through two primary mechanisms: traction and saltation. In traction, the largest and heaviest particles are rolled or dragged along the bottom, much like a bulldozer pushing debris. This is a slow, grinding movement that contributes significantly to bed erosion. Saltation is a more energetic, bouncing motion. Smaller, lighter particles within the bed load are intermittently lifted by the current, travel a short distance downstream, and then fall back to the bed, only to be picked up again. This rhythmic hopping and skipping motion is surprisingly efficient in moving vast quantities of sediment, even when the river appears calm. Recent studies reveal that even in tranquil conditions, sediment beneath the surface slowly creeps forward, highlighting the ceaseless nature of this transport. This continuous movement, especially during peak flow events, ensures that massive amounts of geological material are constantly being relocated, redefining landscapes with every passing moment. But rivers aren't just destroyers, they are also incredible builders. When the river's energy decreases, typically as its gradient lessens, or it enters a larger, slower body of water, it can no longer sustain its sediment load. This leads to gap deposition, where the transported material is dropped, creating entirely new landforms. This is where the patient architects truly construct. One of the most iconic depositional features is the Schwad Delta. Formed at the mouth of a river where it meets a lake or ocean, deltas are vast, fertile wetlands built up by centuries of sediment accumulation. As the river's velocity abruptly drops, it sheds its load, creating intricate networks of channels, islands, and rich alluvial plains. Think of the immense Nile Delta, providing life to Egypt for millennia, or the Amazon Delta, a vast expanse of new land continually pushing into the ocean. These colossal structures are direct evidence of rivers actively expanding continents. Further upstream, as a river matures, Its course often develops intricate meanders, graceful, winding loops. These bends are a direct result of differential erosion and deposition. On the outside curve, where the water flows faster, erosion is dominant, carving out a steep cut bank. On the inside curve, where the water is slower, sediment is deposited, forming a gently sloping point bar. Over time, these meanders migrate across the floodplain, constantly reshaping the valley. Sometimes, two meander loops grow so close that the river cuts across the narrow neck of land between them, abandoning the old loop. This isolated channel, often crescent-shaped, becomes an oxbow lake, a beautiful ephemeral reminder of the river's previous path, which eventually fills with sediment and vegetation, becoming a meander scar. Rivers also create expansive floodplains, broad, flat valleys adjacent to the main channel. During flood events, when the river overflows its banks, it deposits a layer of fine, nutrient-rich sediment across these plains. This regular rejuvenation makes floodplains some of the most fertile agricultural lands on Earth, supporting ecosystems and human civilizations for millennia. Natural levees, slightly elevated ridges along the riverbanks, are also built by deposition during floods, as coarser sediment is dropped immediately upon leaving the main channel. Alluvial fans, fan-shaped deposits of sediment, form where a river emerges from a steep, confined valley into a flatter, open plain, spreading its load in a distinctive pattern. These landforms, sculpted by deposition, showcase the creative power of rivers, transforming eroded material into new foundations for life. The true marvel of rivers shaping the earth lies in the incredible scale of time involved. When we speak of rivers creating canyons, widening valleys, or building deltas, we're not talking about decades or centuries, but millions of years. Geological time, where the slow, persistent drip of water can achieve what no sudden cataclysm could. Consider the Grand Canyon, a monumental testament to the relentless power of the Colorado River. Over an estimated 5 to 6 million years, this river, armed with its abrasive sediment load, has carved a chasm over a mile deep and up to 18 miles wide, exposing billions of years of Earth's geological history. Each layer of rock tells a story of an ancient environment, meticulously unveiled by the river's patient hand. Or look at the vastness of the Amazon River Basin. Not just the river itself, but the immense lowlands it has created and continues to reshape. The sheer volume of water and sediment transported by the Amazon is unparalleled, constantly moving material from the Andes Mountains across the continent to the Atlantic Ocean. This continuous geological work has profound implications, creating fertile soils, diverse ecosystems, and even subtly influencing global climate patterns. The very shape of continents, the location of mountain ranges, and the distribution of rich agricultural lands are in part, a legacy of rivers that have flowed, eroded, and deposited for millions upon millions of years. It's a timescale almost incomprehensible to the human mind, where what seems like an unmoving landscape is in fact a canvas under constant, albeit imperceptibly slow, revision. This intricate dance of erosion, transport, and deposition isn't an isolated phenomenon. Rivers are integral components of the Earth's larger hydrological cycle, the continuous movement of water above, on, and below the surface. They connect mountains to oceans, glaciers to deltas, distributing water and nutrients across vast landscapes. This vital role means they profoundly influence ecosystems, creating unique habitats from the turbulent upper reaches to the slow-moving lower courses and the rich biodiversity of estuaries. They are arteries of life, sustaining countless species of plants and animals, providing essential fresh water and supporting fertile lands. However, human activity has, in recent centuries, begun to exert an unprecedented influence on these ancient architects. Dams alter natural flow regimes, trapping sediment upstream, starving downstream deltas of vital nutrients and impacting erosion patterns. Urbanization increases runoff and pollution, while deforestation accelerates soil erosion, leading to increased sediment loads in rivers. We channelize rivers, modify floodplains, and extract water for agriculture and industry, often disrupting the delicate balance that has evolved over geological time. These interventions, while providing short-term benefits, often have long-term ecological and geological consequences, demonstrating our growing power to both shape and disrupt the planet's natural systems. Yet, despite our interventions, the silent architects continue their work. Even now, rivers around the globe are carving, carrying, and depositing ever so slowly, but undeniably reshaping the face of Earth. They are a constant reminder of the planet's dynamic nature, a testament to the immense power of sustained natural forces. They tell a story of endless change, of resilience, and of the profound, often hidden, beauty of geological processes. So the next time you see a river, pause and truly observe it. Remember the immense power held within its flow, the millions of years of patient work it represents. Understand that you are witnessing one of Earth's most enduring and effective forces, a silent architect continually crafting the world we inhabit. What other hidden geological wonders do you think are at work all around us, shaping our world in ways we rarely notice? Let us know in the comments below. If you found this journey through geological time as fascinating as we did, be sure to hit that like button, subscribe for more captivating insights into our planet, and share this video with anyone who needs a reminder of Earth's magnificent, persistent power. Thank you for watching, and stay curious.